Sara, the floor is yours.
Thank you very much for the invitation. I will here just share some points regarding this short adaptation strategy applied in viticulture, Mediterranean viticulture. That is the application of white clay mineral, that is kaolin. And here we are also sharing the main results of our recent publication in Enology. So in this presentation, I will speak about a little bit of the use of this technology to avoid sunburn damages, a quick overview, what is known about its effects in vineyards regarding reflection of excessive radiation, leaf and berry temperature, vine water status and photosynthetic activity, and the main quality traits in berry and wine. And then share some results regarding the use of this product in two different vineyards, commercial vineyards, one in the northeast of Portugal and the other one in the southeast of Portugal, and then opening a discussion about this topic. To start, I just pick the publications over time regarding this research area, regarding specifically kaolin in Mediterranean vineyards and regarding to abiotic stresses. And then we found that the number of publications is increasing, so the interest in this area is increasing, and mainly they fit in the area of agriculture or food science. So kaolin is a white clay mineral, chemically inert, that easily dissolves in water. It once dissolved in an aqueous suspension and applied over the whole canopy, it leaves a reflective film capable to influence the vine's microclimate at a certain point. And if we are talking of limiting conditions, if we are not talking about limiting conditions or comfortable conditions, this strategy can be very questionable. It forms a uniform layer that transmits PAR radiation, but excludes also some PAR radiation, ultraviolet and infrared radiation. It is nowadays considered a short term to mitigate the damaging effects of extreme temperatures on leaves and fruits. So what is known about kaolin? Kaolin effects in arid and semi-arid regions. It's responsible to increase the reflection of PAR and ultraviolet radiation for any leaves of Cabernet Sauvignon, but also in other varieties, red varieties more specifically, and also the reflectance in the visible domain. Regarding leaf and berry temperature, it has a leaf cooling effect in several 3 or 4 varieties, up to 6 degrees in leaves and up to 4 degrees in berries. Regarding its effects on photosynthesis or the physiological effects, when applied near aeration, it can increase single leaf and whole canopy water use efficiency, the photosynthesis and protection of the photochemical efficiency, or providing photoprotection to the vine, and also increases the content of ABA in Turing medicinal and Saint-Jean's. Regarding berry composition, the results are not so straightforward. They are very variable depending on the grapevine variety, but the common ground is that we found that it can increase the amount of anthocyanins, berry anthocyanins, and total phenolics, tannins, and antioxidant activity, and also reduce sugar levels in some white and red varieties. In must and wine, it's also responsible for increasing color intensity. This is a recent study and related to fruity aromas. But at the same time, those results are not so consistent in white varieties. So regarding this specific study that we published in OENO, the aim here was to understand the effects of this application, of foliar application of kaolin to the responses of grapevine to summer stress that is characterized by high temperatures, light and drought conditions. And we explore the physiological performance in 2 commercial vineyards. The vineyards are very different, they have different features, and the experimental conditions was that we applied during 2 consecutive growing seasons in 2 grapevine varieties. We started our studies some years ago in Touriga Nacional, but then we wanted to see if those results can be also observed in other varieties, such as Touriga Franca, for example, and in other regions. We started in the Douro region, and now we were trying to study also in the south of Portugal. We made a single folder application soon before variation. We have 30 vines per treatment, 2 treatments, a control and a treated one, and 2 sampling periods. We call it variation, or 2 weeks after variation, and here we call it ripening, which it corresponds to the harvest date. During the first year, we can see here the yellow dots are regarding kaolin application when it was applied the day of the year, and then when we do the physiological measurements and collection of some sampling of some leaves. One interesting thing here was that we found that comparing one year to another, that all the sampling stages were advanced in Douro comparing to Alentejo, a situation that was reversed in the second year. So we had like a difference of 13 days of variation and a difference of 20 days of the harvest. And here we measured the leaf gas exchange parameters, soluble solids contents, hormonal content, and expression of some EBA-related genes. The weather conditions were somehow different between one year and another, and for one region and another. Here we had 2 heat waves in 2017 and only 1 in 2018 in both regions, of course. And we had a difference of precipitation also from one year to another. And the number of days with temperatures above 40 degrees also decreased in 2018 compared to 2017. So in here we can have a hint that 2017 was warmer than 2018, and this was very important to understand the effects of kaolin. Regarding leaf gas exchange, we found a general increase of leaf stomatal conductance and photosynthesis, mostly in 2017, and particularly in the at the ripening stage. In 2018, those effects were mostly seen in Touriga Nacional, but were very narrow. At the Alentejo, in the south part of in the southern commercial vineyard, we also found at the ripening stage, in the hottest season that we studied, an increase of stomatal conductance and photosynthesis, but lower in 2018, particularly in Touriga Nacional. So, regarding sugar content in leaves, we found higher sugar contents, particularly in Touriga Franca, in the hottest season that we studied. And in Alentejo, we found the reverse behavior, and no effect or consistent effect in Touriga Nacional. This is also good because it is somehow related with photosynthesis. Since we have more photosynthesis, we should expect this. Then, and regarding ABA, that is related to stomatal closure and stomatal movements, we found that there was an increase of, decrease actually. Yes, the levels of ABA, as you can see, for 2017 are pretty much higher compared to 2018. This was also related to the environmental conditions that were felt at the time. We have here an influence of the variety and sampling here, and the treated vines showed a general decrease in hormonal content in both years. We tried also to see if the differences that we found in ABA content were somehow related to optimization of some other physiological processes. And what we found, we tried then to analyze the NCED gene family that is responsible for the production of ABA, and this gene expression was upregulated in the hottest season, particularly in Toriga Franca, but not in Toriga Nacional in Alentejo. In 2018, we found a consistent downregulation of this gene family, the expression pattern, in kaolin-treated vines, particularly in Alentejo. And what we also tried to analyze after this was, well, if we have some differences regarding gene expression, and that is also related to carotenoids that are very important for photoprotection, how is the photoprotection also? Does kaolin can have a direct impact also in photoprotection or not? The main conclusions of this article were that we found that kaolin application could improve the plasticity of the ability of grapevines to deal with severe periods of summer stress by optimizing the physiological performance and photoprotection mechanisms of vines. And the effects were mainly observed in the warmest season of the study. And we came to the conclusion, yes, it can be generally considered a short-term strategy to avoid sunburn damages. However, we made like a map, to see if how this can be correlated or explain the differences of effects. And the first outcome is that weather conditions, mainly temperature, are the primary trigger in kaolin effectiveness and acclimation strategies in the applied context. Here we have to take into account the interannual variability and intra-annual variability, stress intensity and duration, and what type of climate are we talking about. Then we found that some stress responses, the first one is the leaf cooling effect, and there are several chain effects that can arise from that. That is improvement of photosynthesis, water use efficiency, and photochemical efficiency of photosystem 2. And we also correlated those responses to the photosynthetic pigments. For example, at the Alentejo, we observed more conservation, so chlorophylls were protected or higher in kaolin leaves, but not in the Douro region. The Douro region, we have differences in the ratios of chlorophylls that made us suggest that we have here an acclimation to high light conditions. The berry quality traits are not consistent, the results are much consistent, but there is an increase in anthocyanins and phenolic compounds and also in ABA, that is a ripening promoter. And we found less ABA. So it can be pointed that, but it should be explored, a ripening delaying effect of this product. We should also bear in mind that its effectiveness depends clearly on the stress intensity and duration, timing of application, concentration that is applied, number of applications, and on the vineyard features. Orientation of the vine, variety, age, rootstock, training system, and the association with other management practices, such as, for example, leaf removal. I would like to thank the invitation to be here, and also to IVES and all the partners and the research team that helped me a lot with this. Thank you very much.